In this video sizobe sidiscussa Newton's universal gravitational law. This concept sidiscussa la ku question 5 from this November 2016 question paper. In the description box uzothola ama links for other questions in this question paper. So lana sizobe sidiscussa this question 5 bathi two satellites orbiting the Earth are situated on opposite sides of the Earth. Now planet Earth, umhlaba lo, planet Earth, satellite A, satellite B on opposite sides. Now satellite A has a mass of 3,800 kilogram and satellite B has a mass of 4,500 kilogram. Well, and then satellite A is at the height of 25 kilometers above the surface of the Earth. So the distance from the surface of the Earth, right, from the surface all the way up to satellite A way to its 25,000 kilometers, right? Kilometers. Keep in mind, or I think ama calculations in physics siwayenza in meters, right? If ever you substitute a distance or a displacement or whatever in your formula, make sure that your distance or displacement is in meters. So the kilometers eventually kuzofuneka ukuthi change to ama meters, right? I believe ku question 5.3 so calculate the force, so the kilometers komele abe in meters. But anyway, 5.1 state the law. Every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law is very important. Especially nangabe sekuzoza la uzoyenza ama calculations khona. Okay, I'll point out something nana sekenza lama calculations, but for now let us continue. 5.2, explain the term weightlessness. One time there was this show beyidlala ku National Geographic or National Geographic. I believe i-video yakhona ngayibona somewhere la ku YouTube, where kunama pilot, in fact not ama pilots but ama passengers in a airplane. Sho ukuthi airplane yakhona ila ku planet Earth but just above the surface of the Earth, maybe some kilometers above the surface of the Earth. Leyo aeroplane is not aeroplane yakhona, it's no ordinary aeroplane, it's just an aeroplane specialized kanje. So sho ukuthi kunama passengers ngaphakathi nabafika kuleyo height leyo baba weightless, right? Baba weightless. In other words, it's sort of like a simulated environment. It's just like ku space. Abo ama astronauts nakafika ku space ayenzani, aya bounce around the spaceship. So the same effect happens kuleyo height leyo engikhuluma ngayo. So on that show bebafly bafike kuleyo height and then badlale around kuleyo lokanje kuleyo ngingathini mara ba sort of like uma befika kuleyo height, I think bebadlala or something, I don't remember, but I remember baba weightless. Lana ku 5.2 bathi si explain the term weightlessness. Weightlessness simply means that is a sensation experienced when all contact forces are removed. So the time eba weightless lama passengers engikhuluma ngawo, lawo ma pilots bengikhuluma ngawo lawo, so ukuthi the only force acting at that point kuleyo height or that experience ebeba nayo, it was only gravitational force. There was no friction, There was no push or pull or anything. It was just weightless nje kuphela. The only force be-act lapha is just gravity and the gravitational forces from amanye objects around the bone, right? So that's weightlessness sensation experienced when all contact forces are removed. They were okay. 5.3. What are they saying? Calculate the force between the Earth and satellite A. Kulula ukuthi ikubhayizise le question. I will explain ngichaza ukuthini ngalokho. So calculated force is equal to G, which is a gravitational constant, times mass 1 times mass 2 divided by r squared. The r squared is measured from center to center, right? Center to center. So check out something, Manjula. How about rewrite this formula in this format? Then it's squared, and then this is a h. Now it's still g, which is a constant. Mass 1 will represent the mass of Iloganj of the satellite A, and then mass E is the mass of the planet Earth, and then the distance r, which is measured from center to center. Tinabasipe 25 kilometer distance from the surface to a satellite yet. So we also need the radius of the planet Earth. We also need the radius of the planet Earth. Why ngisho njalo ke? Uthini ulokai Newton's law, Newton's universal gravitational law? Every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional. Okay, this is crucial, and inversely proportional to the square of the distance between their centers. So the center of the Earth is not at the surface, right? So we need the radius of the Earth as well in order to calculate the force. So that's why it's Re plus height. The height, the h now represented the 25,000 kilometers, the height from the surface of the Earth to the satellite A. And then Re represented the radius of the Earth. We need the radius ngoba the calculation is done from center to center. But don't worry, ungawari, on your formula sheet or a table of physical constants, we do have let's see, we do have the radius of the Earth. Nailana is 6.38 times 10 to exponent 6, and then sibenani. I also need the mass of the Earth bakupayona naila, right? So both these quantities is what sevens in our calculations. So let's go calculate the force between what and what, between between satellite A and the planet Earth. So let us substitute again, manje. And then we substitute, boom. So G is a constant, it's 6.67 times 10 to exponent minus 11, and I ukona kuma physical quantity table. And then 3.8 the mass of the satellite A and then even the mass of the planet Earth, physical constant table corner, and then the radius of the planet Earth, 6.38 times 10 to exponent 6 plus the 25,000 kilometers converted to meters. It's 25 times 10 to exponent 6. Bega, it's 25,000, 1, 2, 3, 25,000 times 1,000. Why in times 1,000? You convert a kilometer to meters. So in scientific notation, it's this. It's 25 times 10 to exponent 6. Now I answer. Now the expression here to for the 25,000 kilometer in meters. Now let us calculate again. Fraction, and then it is 6.67 times 10 to exponent minus 11 close bracket. We actually surpass with the close bracket, open another one, 3800 close, open bracket, 5.98 times 10 to exponent 24, close bracket, divide by 6.38 times 10 to exponent 6 plus 25 times 10 to exponent 6 close bracket squared. Our answer is 1539.23 newtons. Since this since the answer is calculator in force, right? So sizoti F is equal to 1539,23 newtons. So this is the force between Earth and satellite A. 5.4. What distance above the surface of the Earth should satellite B be to experience the same force towards Earth as satellite A? Choose from greater than, less than, or equal to the distance above the Earth. Explain how you arrived at the answer. So 5.4. Okay, lana ke. Let us see. Asibone. I think check something. Let me take 4,500. Need to divide by 3,800. It's about to explain how you arrived at your answer. So, Lana, we are definitely going to perform a calculation. Into soyenza. Now, I do have a force. And so, but the force between Earth and satellite B is the same. We want to know the distance above the surface of the Earth, right? Above the surface of the Earth. For satellite B, for was good is over greater than, less than, or equal to the distance ka satellite bunny A. So let me erase and then we do this calculation. All right, now 5.4. So calculate the distance, right? But explain how you arrived at the answer. So this is a calculation that will provide an explanation for this. 5.4. So sebenzisa the universal gravitational law for our forces, right? So F is equal to G times mb, mass of E, satellite B, me, which is what here? The mass of the Earth, and then r squared. The r is the distance from center, is the distance from the center of the Earth to the center of the satellite bunny B, right? The question says what? The distance above the surface of the Earth. So Tina, we are going to calculate the distance from the surface to la. But the r, right? The r is the distance from center to center. So in other words, in whatever value taller for r, subtract the radius of the planet Earth. So that is the distance above the surface of the Earth. Then we compare with the distance of satellite A from the surface with the one yaga satellite B. Then also greater or less than or equal to. Alright, then siya substitute. Someone might ask ukuthi F ngimtholephi. Batheni for the same force towards the Earth as satellite A. So bathi i-force ka satellite, i-force experience our satellite B, the force experience our satellite A, they are the same, right? The forces are the same. Naga the same so nalana you substitute the 1539.29 as on the previous question. So therefore then I cross multiply 1 times this r squared times this, and ngizothola something is so r squared times 1539 comma 23, 1 times that change next lapha. So if we times a number by 1 uthola that number. So lana nothing changes for these brackets. 5.98 times 10 to exponent 24. Divide both sides by bunny, then we divide both sides by 1539,23, cancel 1539,23, right? And then r squared. In fact, let's say r is equal to, since you square up both sides of the equation, r not r squared, so I'm going to take the square root on both sides of the equation. So lana ngisala nalo 3, 6,67 times 10 minus 11, 4,500, 5,98 times 10, 24 divided by 1539,23. So therefore r is equal to, let us calculate, 6,67 times 10 to exponent minus 11, close bracket, open another one, 4,500, and then see 5,98 times 10 to exponent 24, close bracket, divided by 1539,23. This is equal to okay, singayibhala yonke as 148 214,93. So the r, this r, it's meters and it's from center to center. So now in order to calculate the distance above, now the distance above the surface of the earth, sizothi-ke this value subtract, right? This value subtract what's this, the radius of the planet Earth. Ngibheke guys, table of our physical quantities. The radius of the Earth, it's 6,38 times 10 to exponent bani 6. So now subtract the line uthola 2, what's this, 27768 27768 214 93 meters. So this is the distance above the surface of the earth again. So on the previous question, go is tolengaki. Not on the previous question, but check. This is the distance above the surface of the earth. This is the distance above the surface of the earth for Bani satellite A. It's 25,000 kilometers, right? So this one is often with siyenze. So maybe singayithatha sithi divide by 1,000, so that iba kuma kilometers, so that's iba ne comparison iba fair ke manje la, and like a much clear comparison. 768,21 kilometers. So which one is greater, 27,000 kilometers or 25,000 kilometers? Obviously it's this one. So the answer yethu la kuyoba ubani, kuzoba greater than. I-calculation lethu lisuggest ukuthi the distance above the surface of the earth for satellite B is greater than bani, than the distance above the surface of the earth for satellite A. So this concludes our question 5. So thanks for watching. Nangabe enjoyed this video, please leave a like, do not cry, subscribe, ungakhohlwa ukushare nabangani bakho. Nangabune question, let us talk in the comment section. So yeah, in the description box you'll also find links for other questions on pendulile for the question paper. So for now, asibonane on the next video. Bye bye.